Bob Brinkman, and I am the Vice Provost for Scholarship and Engagement here at Hofstra University. One quick note before we move on with tonight's lecture. Our next and final lecture in the Science Night live series is coming up on Wednesday, April 12th at 7 p.m. in this same room, and will be delivered by Dr. Elizabeth Plorin, and the title of her talk is There a Human GPS System? And she will review the science about how we are able to navigate using the power of our brain. So that should be interesting, or maybe not navigate for some of us, I think. One more quick note, after our speaker finishes his presentation, please come forward to the microphones here at the front of the room to ask your questions so everyone can hear them tonight. The subject of tonight's lecture is designer drugs, and this is different from some of our earlier lectures this year and last year that focused on drug discovery for medical purposes. Tonight's lecture focuses on the science of illegal or illicit drugs, especially the forensic science that is used to identify them. We all know that designer drugs are a growing problem in the United States and worldwide, and we've all heard about the various problems with drugs like heroin in the United States. There are about 1.2 million heroin users in the US, and about 1/5 of them are addicted to the drug. And heroin deaths cause more deaths than, or heroin overdoses cause more deaths than traffic accidents. But on Long Island, fentanyl, which is a designer drug, is causing more deaths than heroin. Yet this is not the only designer drug out there. Synthetic marijuana, bath salts, and a variety of other chemicals, many of which I'm sure we'll hear about tonight, regularly make their way into the market. Today's speaker is an expert on the chemistry and detection of designer drugs and is very actively involved with our forensic science program. Our speaker, Dr. Ling Huang, is an associate professor of chemistry and the director of the Advanced Instrumentation Lab at Hofstra University. He received his PhD in chemistry from the University of Virginia, his master's in analytical chemistry from the University of Oklahoma, and his BS in chemistry from Fudan University in Shanghai. His current research at Hofstra includes rapid identification and quantification of designer drugs, e-cigarette fluid analysis, and forensic elemental analysis of gunshot residues. It's my pleasure to introduce Dr. Ling Huang, who will talk to us about designer drugs, a chemist's discovery.
Thank you so much for your introduction, Bob. Today, I'm going to talk about designer drugs. And it's been a 5-year project. I started in 2011, 2012, and now it's been 5 years. When I started this project, I thought it was a temporary problem. But in fact, it actually evolved and keep going on. And became a much bigger problem. So tonight, before I talk about designer drugs, I want to throw out some definitions, because I have my narrow definition of designer drug, which is synthetic analogs or mimics of controlled substances, the illicit drug products that government bans. Usually they're created to evade law enforcement, and oftentimes they're used for recreational purposes, okay? There's also a broader definition I want to bring in today to talk about the designer formulations, because a lot of you probably know about marijuana, and the different formulations will make these drugs work differently in our body. And also, it creates a lot of problems, okay? So I want to also broaden up a little bit, talk about designer compounds and formulations. So as Bob said earlier, there are many designer drugs available that you can buy or you can get from smoke shops, from online, including synthetic cannabinoids, cathinones, phenethylamines or opioids, and they all have their street names, like spice for cannabinoids, bath salts for cathinones, Molly for some of the party phenethylamines, and pink for a special kind of opioids, okay? So I want to start the discussion a little bit history, because a lot of these designer drugs actually have their origin from natural sources. For example, if you take a look at marijuana, about 4,700 years ago, there's recorded history in China. This guy Shen Nong, actually, he went around and tasted a lot of different herbs and found out marijuana actually has medicinal effects. And he actually wrote a book about the effects. That was the earliest historical record. And fast forward to now, and at the beginning of the 20th century, people started to use marijuana like more frequently, and then you start to see it goes into the mainstream toward the end of last century. And then quickly, we started to see designer drugs at the beginning of the 21st century, okay? So the first drug I'm going to talk about is synthetic cannabinoids, and the street name is Spice. But I do want to make some contrast right here, because there are differences between the fake pot and the real pot. So in real pot, the active ingredient is tetrahydrocannabinol, THC, with a molecular structure looking like this. And on the left, I have one of the earlier designer cannabinoids called AM2201. And just by visually comparing these two structures, you can see they look quite different, right? And the way they are made, it really came in 2008. These designer compounds are being sprayed on harmless herbal incenses. They are usually dissolved in a solvent like acetone or ethanol that you can buy from Home Depot or from Lowe's. And you can find tons of YouTube videos showing you how to make them. And then basically they're sprayed on herbal leaves and then packaged, sold as herbal incense products. And you can get them at a smoke shop, local smoke shops. You can get them online for about $10 to $20 a packet. So what they're trying to do is they're trying to mimic the effect of THC, because THC and the regular marijuana, the real one, is still federally controlled, right? And the interesting thing here is these designer compounds, they actually bind to the same receptors in the brain and other parts of our body, and some of them may produce similar effects. However, the biggest problem is spice compounds, they bind to the CB receptor sometimes with greater affinity. They bind, they don't come off. The regular THC they bind, it may come off. So what ends up happening is some users, after taking in products looking like that, and they felt it's harmless, after smoking them, there are a lot of people who got hurt. They either get a seizure or pass out, have really fast heartbeat. There has been a lot of report. I'm sure you've read papers, reports. Time had a big report on that. And a lot of celebrities, had issue with that too. So in my lab, as I said, when I started this research, I worked with one of my colleagues who was a forensic chemist who worked in NYPD. So what we've been finding is it's very hard to keep track of the identity of these compounds. They keep changing. And so we did a lot of research on that. What we found out is there are hot spots and cold spots in these designer drug leaves, which creates a lot of problem because the user take one batch from it, may not feel anything, and then take a second batch, they may get overdose, and they may have a seizure. And because they were made, there's no quality control, okay? And we found on average 1 to 3 cannabinoids, and they have varying concentrations, okay? Some can be as low as 1 milligram per gram of herb. Some can be as high as 50, okay? So these pictures I want to show you, these are the raw powders that you can buy back in 2011. These are the synthetic compounds. And after dissolving them, they get packaged. They get sprayed on herbs looking like that, and then sold as packets like this. Okay, so as a chemist, I want to tell you what I found in these designer drug products we gathered from various sources. And these are the first generation cannabinoids. Okay, so not too much chemistry here. I just want to show you a couple. Like there are 3 classes. You have a 6-member ring with attached to a 5-member ring with an N, and this part of the molecule is called indole. And there are a lot of indole drugs that actually interact with our brain. Okay, and then what people are changing is they have this double bond right here, and on the other side they either have a 2 6-member ring fused together, or 1 6-member ring with 1 carbon right here, or another 6-member ring, no carbon here. So these were the first generation 3 core structures. Then the differences here is you can put different things at these R1, R2, R6, R7 locations. So it's sort of, you can play Lego and put different Lego pieces together, and then you get your designer cannabinoid. Okay? So when you have these different pieces on there, you get these compounds, AM2201, JWH18, and 250, RCS4. Every one of them either come from an academic lab or they come from a company, a pharmaceutical company. They try to make new painkillers, new pharmaceuticals. So I just want to give you a little brief history because the first generation, there were a lot of JWH compounds. JWH compounds came from Professor John W. Hoffman's lab in Clemson University. He's retired now, but back in the mid-90s, he's been making a ton of these JWH compounds, which he hoped to use as the next generation painkillers. Okay? The AM compounds came from Professor Alexandros Markrianis' lab in Northeastern University in Boston. And he's still pretty active. He's still making AM compounds, the cannabinoids. Okay? Most of their efforts are funded by NIH, National Institute of Health, because their goal is to find the next generation painkillers. However, back in 2008, these compounds got into wrong hands. First, it was discovered in Europe, in Germany. These drugs are being sprayed on herbal leaves and sold as incense. And then quickly they migrated to Japan, to other developed countries, and then it made it to the United States about 2010. And the problem is still going on right now. However, back in 2013, 2012, federal government passed a law banning 5 classes of designer drugs, including those 3 classes of cannabinoids and some cathinones. Every state and every local government have some sort of laws banning various chemicals. Once these got banned, we started to see 2nd generation of cannabinoids appearing. The difference is here, instead of having a 6-member ring, you have a 3-member ring here. Instead of having a 6-member ring, you have a Kg molecule or function group we call admental right here. And instead of having carbon, you have a nitrogen right here. So when you make these Lego piece switches, you're not breaking the law. These compounds became legal. And what happens is when these compounds got on the street, Drug Enforcement Administration, started to pay attention. And if people got harmed, they will temporarily put them into Schedule 1 controlled substance. Then they became illegal. It became illegal to sell them or buy them. Okay. Another thing I want to point out is this one has another nitrogen, so it went from indole to something called an indazole. And Then you have the third generation, and you can see the changes people are making here. Instead of having two carbon 6-member ring, you switch one carbon out, replace it with the nitrogen, then it's legal, right? And then here you add an oxygen, and you avoid the coverage of the current law. This is the third generation, and then you have these ones and these ones, these ones. I won't go into the detail. Then once these got banned, you have the fourth generation, and some of these are still on the street right now, even in this state. So you start to see changes, they swap out the carbon with this nitrogen, and over here you have, instead of rings, you have these functional groups, okay? And you have the cage again with oxygen. So these compounds are still legal at this moment, okay? Still harming people. So that creates tremendous amount of challenge for law enforcement, specifically the crime labs. How do you play the catch-up game, right? Because it keeps changing, and usually the cycle is about 6 months to 1 year, before these things start to show up on the street and being identified. So the traditional way of finding these out, the gold standard method in crime labs is called gas chromatography with mass spectrometry detection. So typically you have, you extract these compounds with a solvent like methanol or acetonitrile. You inject it through a column where things get separated based on boiling point. And then after separation, they get into mass spectrometer identified based on the fragments generated at the detector. One drawback with this method is it's a destructive method, and with mass spectrometry, you're looking at fragments, you're looking at Lego pieces. The Lego pieces could be put together differently, linked together differently. So it creates a lot of problem to identify the isomers. Isomers are compounds with the same molecular formula, different structure, okay? So just a little bit research promotion. The next couple of slides, I'm gonna show the research work is done in my lab with all undergraduate students. So our solution here is we use NMR, nuclear magnetic resonance spectrometer, and this instrument is located next door in Berliner Hall in the basement. It is a non-destructive method, and it's very sensitive. Compared to GCMS, you can actually look at the linkage between the Lego pieces. And so several undergraduate students work with me, and we've found out with a very simple extraction method, we can get answers, qualitative and quantitative answers within an hour, which is comparable to the gold standard method. And in some cases, better than the gold standard GCMS, the gas chromatography mass spec method. So I just want to show you 3 slides of our data. So this one, I'm showing you proton NMR, 1D NMR. There are 3 spectra in 3 panels. On top, what I'm showing you is the base leaf, the non-harmful herbal incense leaf. This particular one is called mugwort. And as you can see, it produced some signal here and here, okay? The middle panel, I'm showing you one of the synthetic component, RCS04, that people use to spray on the herb. So this is the pure powder, if you will, okay? So you're seeing a couple signals right here. The third panel, I'm showing you the street drug called Moonspice. And we did an extraction, we did a spectral scan, and we found out the signal aligns perfectly with RCS04. And there's turned out to be another compound in there. As you can see, there are extra peaks right here. It turned out to be JWH18, which is one of the first 5 banned synthetic cannabinoids. And all that process, generating that spectrum, took 4 minutes, okay? And then this slide, I'm just showing you a technique called COSY, proton-proton correlation spectroscopy. It was also an NMR technique. So you get 2 dimensions, and you can differentiate molecules that are really close to each other. So this one is called UR144. This one is called XLR11. So these two are pure powders. The only difference is here. So here you see CH3. Here, one of the hydrogen is replaced with a fluorine atom. So that's the only difference between these two. And in conventional methods, including GCMS, it's very difficult to differentiate them, okay? And what we found out is we ran a street sample called Cloud9, and we were able to link the COSY signal to their standards. So we did find there's UR144 and XR11 on both of them on Cloud9. And it turned out to be quite high amount, 50 milligrams per gram of herb. The reason why they had to put so much in there because of the 3-member ring made it really weak. So the effect is really weak. You have to take a lot to feel anything. So in addition to identification, we also tried some quantification. So what we did is we added internal standard maleic acid. So it served as an internal ruler to measure how much cannabinoid is on those herbal incenses, okay? So next, I'm going to talk about, switch gears a little bit to talk about designer formulation of pot products. Because you can get marijuana products in many different formats, right? And I want to bring it to your attention because when you talk about pharmacology, the way of drug delivery, the amount in them matters, right? Because most of the people here know that there are 2 active ingredients in marijuana. THC, tetrahydrocannabinol, that usually gives you the high. CBD, is the other compound that potentially has pharmaceutical benefits that can be used to cure, epilepsy symptoms. But in fact, there are about 25 cannabinoids in pot products with various concentrations. And there hasn't been enough research done or enough methodology to control the quality of these products, to give you the right formulation and consistent formulation. So that's a big problem that, with medical marijuana being legalized in 14, 16 states now, and recreational marijuana being legalized in 8 states now, that creates a lot of challenge for analytical chemists like us to, control the quality of these products. And another issue is, you increasingly see these form of designer drugs in food, right? In brownies, in candies. I've heard students on Hofstra campus who tried these candies, and it could be a pretty scary experience. Because if you don't know how much is in there, it could really take a toll on you, okay? So that's why you have to be careful when you're consuming designer drug products, okay? So after cannabinoids, I'm going to move on to talk a little bit about the other designer drug compounds. Next topic, I want to talk about cathinones. And cathinones have their origin from the plant cat, okay? And that's where it got its name, cathinone, okay? And this plant is routinely consumed by people from Middle Eastern countries like Yemen or from Africa. So people usually chew the leaves to get stimulation. It's a stimulant, but if you chew a lot of it, you can also get hallucination, okay? And it's been used for hundreds of years, and there are recorded history about that. Right around the same time cannabinoids start to be found on the market, these things start to emerge called bath salts. You don't really take a bath with these, just like you don't use the spice to cook or make a tea, okay? These are usually marketed as bath salts to avoid law enforcement. What's really in them are derivatives, or we say close cousins, of cathinone. If you look at it, there's a 6-member ring, CO double bond, and amine group, and you add a little bit more, add 1 methyl here, and you get a designer synthetic cathinone, okay? It worked as well as cathinone, okay? And this particular one is called methadone, and there are a dozen of them at one point on the market. And you probably remember that at one time, around 2011, 2012, there was a big high-profile case in Florida. Like one person is eating the other person's face, right? And some people blame it on one of the cathinones called alpha PVP, which has this structure, but it wasn't proved, okay? So right now, unfortunately, this usage of cathinone is going down nationally because of the danger and education. And spice, unfortunately, is still going on. And even last year, I heard from my student who did an internship in a local hospital, and last summer he saw like 20 cases just on Long Island, one at the hospital here. All right, so the next designer drug I want to talk a little bit about is phenethylamines or Molly drug. A lot of you have heard about methamphetamine, okay, which is another stimulant, and it looks somewhat similar to the cathinones because they are all related. They all, the brain chemistry are related, okay? And what happens is, at the same time, spice and bath salts are emerging. There are designer phenethylamines like Molly, and this is one of the examples called MDMA. And I want to show you the story. There's actually a long story. This compound was made originally by Alexander Sasha Shulgin, who was an organic chemist, and he sort of lead the designer drug effort back in the 60s. He's arguably the father of designer drug in this country in the modern history. So what he did is he had made hundreds of compounds. He actually tried them, in a very safe manner. He had, like, every Friday, he had invited friends over, and they start with a very small dosage, and then he had a well-documented experience, and he was using himself and his wife and friends as test subjects on the compounds he made. And he wrote 2 books about it, and they're free online, and you can check them out. So a lot of the compounds actually came from his lab, the phenethylamines, okay? So this is one of them, and you can find them in many different forms, in pills, even in gummy bears, and a lot of these drugs are used, to enjoy music in concerts. Like you see them in electronic music concerts and party scenes, etc. And another person I want to introduce to you, which is an important figure in the international scene of designer drug, Matt Bowden. He's a New Zealand rock musician. So he was sort of the anti-government kind of figure, and he's like libertarian leaning figure, and he's all for legalization of all drugs. So he had a lab, really well-established lab. He hired a bunch of chemists. He made a lot of the drugs that, Sasha Shulgin proposed, and also some of the newer designer cannabinoids. Then what happens is, after he found some of them really works, he had them made overseas, typically in China, around Shanghai. There are a lot of factories that can mass produce these compounds, and for very low cost. Then he shipped them all over the world because it's legal. They're sold as research chemicals, okay? And if you go online, you can find a documentary featuring him, and he take you to those labs and see how they're made, okay? Another designer drug, if you will, from nature, psilocybin. The chemical formula is shown right here, and they're found in these kind of mushrooms, and they can give you hallucination. You probably heard a little bit about them. Peyote, it's a cactus, which contains mescaline. It's also a phenethylamine, okay? Give you stimulation and hallucination as well. But The difference here is you find a couple more OCH3s, we call methoxy groups, on the 6-member benzene ring. All right, so next I want to talk a little bit about the Controlled Substance Act, because I've been talking about legalization and illegal. So what is an illegal controlled substance? There's very strict definitions defined in Controlled Substance Act, which was signed by the president in 1970, okay, and by President Nixon. Schedule 1 substance is defined as any compounds with high abuse potential, no approved medical use. Here's the controversial part. No approved medical use. So you see what's in the list. LSD, psilocybin, heroin, marijuana, cannabis, ecstasy, some synthetic cannabinoids, and casinones. So the key word here is approved. So right now there's a big debate going on about cannabis, right? Some people say it has medical effects. However, there has been several rejections of rescheduling cannabis because there's no approved medical use, okay? Approved meaning FDA approved. The bright side about this is there's several FDA-sponsored clinical trials going on with cannabis, and there's been more approval by the government to do pod-related research, to try to find the medicinal benefits of that. So I'm hopeful that in our lifetime, these drugs will be, at least marijuana, will be rescheduled. Schedule 2, what do you see? You find cocaine, oxycodone, painkillers, fentanyl. Fentanyl is actually not a designer drug. It is a pharmaceutical compound made by Janssen Pharmaceutical. Morphine, opium, codeine, and hydrocodone. And they have some sort of medical use. Sometimes historically they're used as medicine, but they still have very high potential for abuse, may lead to addiction, okay? And some of the phenethylamine I've been talking about, amphetamine, methamphetamine, Ritalin is used to treat ADHD. These are Schedule 2. Schedule 3 have potential for abuse less than Schedule 1 or 2, and it leads to moderate addiction. So you will find some formulation of Tylenol that contains codeine, ketamine, which is relative to phenethylamine, and it's being also tested by FDA for some treating some depression right now. Okay, some anabolic steroids used for sports cheating. Schedule 4 includes some prescription drugs like diazepam. People take it to treat psychological conditions and treat anxiety, okay? And then you have Schedule 5, which is the lowest level, okay? All right, so now I want to bring your attention to this picture. This picture went viral last year on Facebook. These pictures were shot by police officers in Ohio. They put it on Facebook to show the reality of heroin addiction. So you see the two parents, injected too much heroin, and they have their 4-year-old son sitting in the back seat. It was really heart-wrenching picture. And unfortunately, we're still going through this national opioid pandemic. And the next couple of slides, I just want to show you how it got started and where we are in this pandemic. And then I want to present to you the direction it is going and maybe some of the solutions. Okay, so opioid pandemic really started when Purdue Pharmaceutical Company started to push the painkiller, the blockbuster painkiller, oxycodone. And doctors were overprescribing it, the users were using it and abusing it. And it's very strong. It interacts with your body, and is a great painkiller, gives you a lot of relief from the pain, from surgery, from back pain, from sports injuries, for example. But you're only supposed to be taking it for a short period of time. But a lot of people were taking these for weeks or months, and then they start to get addicted to this compound called oxycodone. And if you look at oxycodone, it's very close to heroin, the core structure, as they interact with the same micro-opioid receptor in the brain. Okay? So heroin is coming from morphine. Morphine comes from opium. Okay? All of these are painkillers. But the big problem of them is you can get really addicted to them, right? So if a lot of you might remember like oxycodone addiction that was quite prevalent back in 2012, 2013. And there was one guy I remember reading on the newspaper in Seaford robbed a local pharmacy and killed several people. Just he's trying to get oxycodone because he's addicted to oxycodone. Then nationally, the law enforcement started to crack down on the prescription of oxycodone. So they really limited the supply of oxycodone. And several doctors throughout the country got arrested for overprescription, serving as pill pushers. Then at the same time, we started to see very cheap heroin started to emerge on nationally in the US market. Because part of the reason is there's more and more legalization of pot. So people can get pot from the US producers. So some of the Mexico drug dealers or drug producers, they stopped shipping pot, which smells really strongly. They start to produce a lot of heroin or trying to transport heroin from the south border to here. So the market was saturated with a lot of high quality and inexpensive heroin. So the people who couldn't get oxycodone, they went for heroin. Then we started to hear stories about heroin overdose, and this really started to crack down on heroin. Then you started to see fentanyl, another Schedule II controlled substance, emerging as a replacement of heroin, in some cases mixed with heroin. Fentanyl is also a very strong painkiller and interact with the micro-opioid receptor. However, the structures between heroin and fentanyl, you can see, are drastically different, right? Then you start to see fentanyl being controlled more tightly, and you start to see on the news, people start to use carfentanil, which is designed to put down elephants. It's elephant tranquilizer. It's 100 times stronger than fentanyl and 10,000 times stronger than heroin. So there were a lot of overdoses associated with carfentanil. At the same time, you also see designer painkillers or opioids like U47700. Stream name is called Pink. And just in New York State alone, there were more than 50 reported overdose cases associated with Pink in the past year. Okay, so since these got reported, several of them got put on much tighter control by DEA and local government. So it's becoming harder and harder to get your hand on any one of these. So the people who got addicted to opioids, they have to go to look for something to get their fix. Then it came these, because you can order these online. These are close cousins of either fentanyl or Pink. Okay? You start to see these, and you start to see these. You start to see these. Okay? And these, a lot of these are still legal, and you can order them from the internet, but they're as harmful. Okay? So one of the remedy for these opioid painkiller is Narcan, and it saves life. So you take one of these injectors and puncture the leg or arm for the user who is experiencing overdose, and what it does is the molecule will knock the opioid off the receptor. Okay? It works to some extent because, as I said, the opioids, some of them bind very strongly at very low amount. So sometimes you need double, triple doses of Narcan to get it to work. And you have to act very quickly because if it's too late, the user usually gets suffocation and they start to have trouble breathing, and they will die in minutes, if not in hours. Okay? Another solution to this national opiate pandemic, again, we can go back to the natural roots. This product is an herbal product called Kratom, and you can grind it up into powder and drink the tea. It's very bitter, but what it does, for those people who are addicted to opioids, they can suppress the symptoms, and it's less harmful compared to the synthetic opioids. However, late last year, DEA was proposing to schedule it as Schedule 1 controlled substance, and they immediately got like 20,000 comments, talking about why it's the wrong choice. Their base for scheduling it is they found 14 people who got overdosed, and they were blaming it on Kratom. In fact, people found out those 14 people also were taking other synthetic opioids. So they didn't really know it was Kratom that created those overdose cases. So with so much backlash and the comments against the scheduling of Kratom, DEA finally decided to postpone the scheduling of Kratom. So that might be one of the temporary solution to control them. On the other hand, DEA has been very aggressive in controlling the manufacturing of these synthetic opioids. They recently had a new agreement with the Chinese government in controlling the production of the raw ingredients, which can be used to make these fentanyl derivatives, okay? Which I think is unprecedented. I think they are making the right moves to control the production of these and supply of these, so you won't be able to even see them in this country. Okay, so I'm finishing my talk. I think my time is almost up, but I do want to show you this slide that shows you the various psychoactive substances and their harm, okay, their relative harm. So on the y-axis, I'm showing the dependence potential. The higher they are, the more dependence potential they are, the more dangerous people can get addicted to. On the x-axis, I'm showing you the active dose versus the lethal dose. The more to the left means like if you take just a little bit to feel the high or feel the effect, you only need to take a little bit more to be dead or to feel the lethal effect. So the more to the right and the more up are the more harmful drugs. Let's take a look at where alcohol is. Alcohol, in terms of dependency, is right in the middle, but it's got very high active versus lethal dosage, which means you just have to drink a little bit more to cause death, right? And you look at where caffeine is. Caffeine is really low on the moderate low on the dependence and moderate on the active versus lethal dose, okay? You see where marijuana is, right? Marijuana is very low on dependency, and in terms of active versus lethal, it's 0.001. That means you have to smoke a ton of pot to cause any harmful effects, right? And then you look at the other drugs I've been talking about. Heroin is way up right here. Cocaine is here. MDMA is right here. Mescaline is here. And nicotine, for people who smoke, got a really high dependency and pretty high active versus lethal dose. So this chart gives you the scientific comparison of the harm of these psychoactive substances. You can actually find this online and from Wikipedia. All right, to conclude my talk, I want to show you my finding. So when it comes to designer drugs, the line is often blurred between therapeutic and recreational, between licit and illicit, between crime and disease, between having an edge and cheating, that applies to sports, between toxic and beneficial, between synthetic and natural, between analogs and non-analogs, between scheduled and non-scheduled. Okay, with that, I'd like to end my talk, and I'm happy to take any questions. Thank you.
So do you find with the designer drugs, you mentioned that they change the affinity of the drug for the receptor. Do they also change the way that some of these receptors signal? Like change the way that they activate different cellular pathways, or is it more of a prolonged signaling event?
That's a good question. The papers, the reason why people know they work with the same receptors is because they were in vitro studies. So people were basically doing the cell assays in petri dish. So when John Huffman and Alexandros Makarianis were making those compounds, they actually did the cell study. But they didn't talk too much about how cell signaling and stuff like that. There were not enough biological study with them. Because I'm a chemist, so I didn't dig deeper enough. There might be literature out there to show various classes, how they work, but my understanding is from what I read from the literature is if you have the endocannabinoids, they pretty much work the same way.
Okay.
Because computational studies suggest they bind into the same pocket in the CB1, CB2 receptors. And CB1, CB2 receptors are well characterized with crystal structures and the signaling pathways. That's well studied. Okay.
Cool. Thank you.
I have a very similar question. My name is Jacob. I'm a student here. And the question I have is really these different substances that are variations, that are synthetic versus the original substances. If they bind to the exact same receptor, does that mean they produce the same effects? Because you said that they have different shapes and that they can drastically differ in how lethal they can be and how dangerous they can be.
That's a great question. So typically, as I said earlier, they bind to the same pocket, but with different strengths. Okay, so some of them bind more tightly than the other ones. The one bind more tightly might be more harmful. And also, in the case of cannabinoids, there are two different kind of receptors, CB1 and CB2. They have slightly different signaling pathways. So some of them bind tighter to CB1, the other ones bind tighter to CB2. So they will create different effects. And from what I studied, like at the beginning, a lot of users were posting YouTube videos after they smoke one type of the spice product. And some people were showing, they got hallucination. The other people were showing like they got rapid heartbeat. And the other people were having a fever. And there were people who got seizure. I think not only the structure matters, but the quantity matters. Because some people were taking too much. And it also depends on the body chemistry, because some people are more tolerant. If they're chronic drug users, they are more tolerant to the drug itself. So really there has to be more study on the effect of these. But one thing I can tell you is you make a small change, you add a carbon CH3 on the molecule, it will be depending on where you're adding them, it could be an on and off effect. It may turn off that receptor.
And I have another question, a follow-up question.
Yeah.
Has there ever been an instance where a synthetic compound that was just newly discovered on the street or whatever was deemed not a controlled substance?
Yeah,
okay.
It happens every day. As I said, usually something got banned and it would disappear from the street, and then next week some new thing is going to emerge because they have very quick cycles like Matt Bowden and the chemists in China, and when they are making these compounds, they are following the law because they obviously didn't want to break the law. So they are making only legal products. So they will study the law and make sure the law is not covering, the stuff they are making to avoid law enforcement,
I
prosecution.
want their lawyers. All right, thank you.
All right. Yeah, but there's a lot of controversy. I think to follow up on that question, there has been a debate among forensic science community on what is an analog. Because as I said, the national law is pretty clear. They ban 5 classes of compounds with very clear structures. And they show the examples. They name the compounds. But state laws, it depends. Some states will say anything that binds to CB1, CB2 receptors is a cannabinoid, and they are considered a Schedule 1 controlled substance. That creates problem in law enforcement because our human body produces endocannabinoids. There was a recent paper that's published in PNAS talking about runner's high. Runner's high actually came from the cannabinoids our human body makes. So there's no way you can control all cannabinoids because our body keeps producing them. Not one, I think 5 of them that we know the structure of.
Thanks for the talk. Very interesting. So we often hear with the heroin crisis, the narrative in the media, sometimes they try to say, well, heroin addicts are victims, and other people try to vilify them. So from sort of the chemical point of view, do you have any insight into which narrative is more valid?
I think, as I said in the last slides, the line is blurred, right, between a disease and a crime. And immediately, I think as a chemist, my solution is we got to treat these people, right? We're going to get them off the opioids. I mean, there are many different ways. Detox clinic, there has been debates on if they work or not, right? And another solution is you can do that in your kitchen, just make some kratom tea and drink it, right? But the bottom line is you got to save these people, get them off opioids. I think that's the number one urgent measure we have to take. And it's still going on. A lot of people are still addicted to these opioids. And banning all the synthetic opioids does not help. You got to have other measures to mitigate the effects. And usually these substance abuse are associated with other problems, societal problems, poverty, lack of parents, and drinking problems maybe, and financial issues. So we got to treat it as a comprehensive way, as a comprehensive problem. I think all stakeholders have to get together, and obviously resources have been spent to at least get them on the right path. I'm sympathetic to the people, especially those people who got addicted through painkillers, like taking oxycodone, because they had sports injury, for example. I've heard a lot of stories, even at Hofstra, I've heard stories about that, like some athletes, got injured, and they had to take painkillers, and they've been taking too much, and then got addicted to opioids. I'm really sympathetic to them, and I think these people deserve our care and our attention.
So you said before that our body produces chemicals similar to these opioids. Is that why you'd say that the opioids are so successful at getting us high pretty much is because they mimic the hormones and chemicals that our own body produces to make us feel a certain way?
They are linked. They are related. Let's put it this way. They are related. Although I don't have the picture here, the endocannabinoids, they actually look quite different from any of the cannabinoids I've shown today. If you're interested, just search. I'm happy to show you the papers and you can read them. They still bind to the CB1, CB2 receptors. However, the cascade mechanism is slightly different, but the high is the same high. A lot of them lead to the same end results. But the way, how long it lasts, how much does it take to feel the runner's high, it's different. Because as I said, dosage, formulation matters, and location where those cannabinoids are generated is different from you smoking it through your, ingestion or through your nose. That's different. That's different delivery, right? So you will find different concentrations in different parts of your body.
Cool. Thanks.
Well, please join me in thanking Dr. Ling Huang for a terrific talk
Thank you.
tonight.
Thank you very much.
Really
Yeah, thank you.
interesting. And we'll see you on April 12th for our next Science Night Live event. Thank you.